Hey folks, welcome to the Neo4j Twitch stream. My name's Will. Sorry I'm a little bit behind schedule today. Just had a little minor issue to take care of, but should be okay to get started. So here's where we left off last time. So just a refresher, this is now part 5, I think, of building our real estate search app with GRANDstack. We've been spending a lot of time working on data import in Neo4j and building out our GraphQL API, which is what the focus was last time. The focus last time well, let's take a look at the GitHub repo, actually. So I'll drop that in the chat. The link there if you haven't seen that. So this is GRANDstack Willow in the data directory. This is where we have the scripts and queries to import the data. A couple sessions ago, we pulled down shapefiles on parcel information, imported that into Neo4j, first converting it to GeoJSON, then using APOC load JSON to put it into Neo4j. Then in the last session, we took a look at this Python script to scrape the property record website that had a bit more information for each parcel that was not found in those shapefiles. So things like the neighborhood that the house is in, the size of the house, the size of the lot, number of bedrooms, bathrooms, that kind of thing. And that Python script created a couple of CSV files, which we then pulled in to Neo4j with Neo4j load CSV and Cypher. And then, so once we have the data in Neo4j, then last time we were using GraphQL Architect in Neo4j Desktop. So GraphQL Architect, this is what's called a graph app. It's an application that we install into Neo4j Desktop. In this case, it helps us build and query local GraphQL APIs. So let me drop the link for has the instructions to install GraphQL Architect. If you didn't see that last time, basically we just copy this link and paste it into Neo4j Desktop. I'll drop that in the chat. Okay, so that brings us up to speed on where we were last time. Today, I want to, I guess, first of all, finish off where we were with GraphQL Architect, with our GraphQL API, and see how we can export this GraphQL API that we built to our GRANDstack starter, which is the project that we started from back in the first session, right? So we were using the Create GRANDstack app to build out the skeleton of our application, and then we deployed that using Netlify and the Neo4j Sandbox. In the first session, now what I want to do is show how we can go from having our GraphQL API that we've built with GraphQL Architect, export that to our GRANDstack starter project. And then we've been ignoring the front end a bit, so I want to spend some time updating the skeleton project that we have in GRANDstack starter, which is this kind of dashboard application for business reviews. So we'll change that to work with our real estate data model. And then I've had some folks ask about how do we deploy this to a real Neo4j instance in the cloud somewhere. The first session we did Neo4j Sandbox, which is great for kind of development, but what do we do for a more long-term running solution? So I think we'll take a look at how to deploy to Neo4j Aura. If you're not familiar with Neo4j Aura, this is Neo4j database as a service. So it allows me to spin up Neo4j instances in the cloud. I can scale those up and down. It gives me a cluster, really. It's more than just a single instance. So today we'll try to get our app up and running on Neo4j Aura and Netlify after we make some updates to the front end. And then I want to take a look at adding a map component to our application. Cool, so let's get started. Okay, so this is where we left off last time. So in GraphQL Architect, we had created the GraphQL type definitions for our API. So here I just clicked on Start Local Server. And here's the GraphQL query we were running at the end of last time. Let's bring that down so we can read that a bit better. So in this case, we're searching for properties using some of the built-in filtering that we have. Can I make that a bit bigger, easier to read? Yeah, let's zoom in a bit. So we were using some of the built-in filtering that we have in the Neo4j GraphQL.js library, which is the library that powers, so that's sitting underneath GraphQL Architect, which is powering the GraphQL API that we're running. And specifically, if we want to look at the documentation for this, GRANDstack.io, this is the site that has the documentation for Neo4j GraphQL.js, and specifically, we're interested in the filtering functionality. I'll drop a link to that in the chat. Okay, so we're taking advantage of this filtering to search for, properties that have more than 4 bedrooms, more than 3 bathrooms. So this is bedrooms underscore GT for greater than, right? We could also do less than, equal to, and so on. And then we have a specific point. This was latitude and longitude for Montana State University. So we're searching for houses within 1 kilometer of this point that meet these criteria, and then getting some details about them. Cool, so now we want to deploy or export this GraphQL API project to what we were working with in GRANDstack Starter. So the GRANDstack Starter project that we created last time, and again, this was done using the Create GRANDstack app CLI. So Create GRANDstack app, that is what we used to create the skeleton application that has both the code for our API and so far, so I think we had used the infer schema functionality in the GRANDstack Starter at some point, and we had this version of a very simple GraphQL API in schema.graphql. If we look at index.js, what's going on here? So this is index.js for our API application. So this is our Node.js GraphQL server. What it's doing is it's pulling in that GraphQL schema. Here are the type defs that are defined in schema.graphql. It's pulling those in. It's using make augmented schema from this Neo4j GraphQL.js library to create a GraphQL server using Apollo server, and then serves that on localhost 4001. So what we want to do is, how do we export these type definitions to our GRANDstack Starter project? Well, one thing we can do, let's do cd API source. So this is where our schema.graphql file lives. So if we take this location, one thing we can do in GraphQL Architect is export the schema. So if we look at our deploy options, These are a bit work in progress. GraphQL Architect is still fairly new, and I think we can explore some other export and deploy functionality. For now, what we can do is export this schema.graphql file into our GRANDstack starter project that we have locally. I'd be curious to know what other deployment options folks would be interested in. We're thinking of things like a GitHub integration, maybe deploying specifically integrated with Netlify, maybe Versal, maybe AWS Lambda, those sorts of things. But anyway, chime in the chat or the comments, or feel free to ping me directly if you have thoughts on what sort of deployment integration you'd like to see in GraphQL Architect. Anyway, for now, we're just going to write this file to our GRANDstack starter project. So I'm going to stop the local GraphQL server that's running in GraphQL Architect, switch over to my GRANDstack starter project, look at my schema.graphql file, and yep, it's been updated with the type definitions that we created last time in GraphQL Architect. Cool. So I can run npm run start to spin up both the GraphQL API and the dev React web server. But before I do that, I want to take a look back at the index.js code for my GraphQL API. So first, let's tweak a couple things here. So we calling make augmented schema in the version that we started, if you remember, back to the first session where we had a schema of business reviews and users and ratings, we had this sort of computed type that we were excluding from the auto-generated GraphQL API from make augmented schema. So we don't have a rating count yet. That's fine. We can leave that in there, though. I don't think that'll cause us any problems. The other thing I want to look at is the initialize database step. So this runs initialize.js and calls apoc.schema.assert and passes in what looks like some sort of configuration for setting constraints based on our old schema. So what is this doing? Well, let's take a look at the docs here. Apoc schema assert. So APOC, we've said, is the standard library for Neo4j. It includes a bunch of helper functions and procedures. And schema assert is one of them that drops all other existing indexes and constraints if this drop existing flag is true, the default is true, and asserts that at the end of the operation, the given indexes and unique constraints exist in the database. Cool. So it takes two objects. The first one is index labels and index keys. So for any indexes we want to create, and then the second one is constraint label and constraint keys. So for any existence or uniqueness constraints, rather, that we want to create. So if we look at, I'm going to close out of GraphQL Architect. I think we're done with that for now and switch to Neo4j browser. And if we do a colon schema to see the indexes and constraints that we created, some of these we created last time, but some of them, if you remember, every time I opened up my database, I had these new business review constraints. So we were wondering where those came from. So this is where they come from. Because I had started our GraphQL API that went through the initialization phase, it was creating these old constraints, which I don't want anymore. So let's update this before we start the API again. We want, let's see, business we don't care about, category we don't care about, neighborhood name is unique. So instead of user, capital N, neighborhood, and that's just name. Property ID is unique. So instead of business, we'll say property ID. And then instead of review, we don't care about subdivision. We do care about, subdivision has name. D sub division name, and then category we don't care about. So let's just delete that since we don't have a category in this data. Okay, so this second object that we're passing, these are the constraints that we're creating. The first one is any indexes. I want to create an index on the location property. So let's jump back to Neo4j browser, match p property. Let's just look at the first 10 of these. LB cattle co. Okay, so this property node has a location that's a latitude and longitude, and because we're using that in the filter, I want to create an index, a spatial index. So then this is using an index to find these efficiently. So we'll create that here, property location, which will create an index on the location property on our property nodes. Okay, so save that, and let's cd out to the root of our project. And if we do an npm run start, let's see what happens here. So this should start both the development React web server, which this is opened automatically, localhost 3000. So that's building our React app. And then it says our GraphQL API is ready at localhost 4001/GraphQL. Let's check that out. So here's GraphQL Playground, which allows us to write some queries. We can check out the docs tab, city, subdivision, neighborhood, property. Cool. Let's just write a simple query that says, show me all the cities. Great, got some cities. Let's check next our .env file to make sure we're connected to the right database. So yep, localhost 7687, which is the default for a locally running database, which is this one in Neo4j Desktop. Previously, we had connected this, I think, to a sandbox instance that went away. So that's the right connection credentials in this .env file, which is what's used by the GraphQL API to connect to Neo4j using the Neo4j JavaScript driver. If you want to see exactly where those are being used, it's using this .env library to set those as environment variables. And then here, when we're constructing the driver instance, we're using those environment variables with a fallback to the defaults. Okay, so let's check out the React application. So if you remember, the first time we ran this, when we had the sample data and our business reviews schema, we had kind of this dashboard view that was showing us how it had like a chart of the distribution of stars of the reviews, I guess, here, and it had like the number users in the database, a simple count here, and then here it had like a table of business reviews. So kind of a dashboard view, but of course we're getting errors because we have changed the GraphQL schema that the React app is trying to query. If we open JavaScript console and go to network, let's do a refresh. Just the XHR network requests, which are our GraphQL requests. We can see we're making 3 GraphQL requests. And responses, we get a 400 bad request. You can see the query that we're running. So the query we're running is here. So ratings count, then bringing back stars and count and type name. And if we look in the response, the message is cannot query field ratings count on type query. So these are the 3 GraphQL queries. Each one of these components individually is sending. So let's jump into the code to look at that. So in the web React directory, we've got source. Then if we look at app.js, so there's some styles here and kind of the boilerplate things that are handling like this drawer sliding open and some things like that. The toolbar up here with our logo. But if we look here for sort of the main content of this component, we're using a React router and a switch. So when the path is just the root, we load the dashboard component, and when it's /business or /users, we load this user list component, right? So here at the root, this here in the middle is the dashboard component. If we click here, we switch to /users, and using React router, we're loading this user list component, which is also erroring because it is using a different GraphQL query than what we have in the API. Okay, so we're interested in components dashboard. And if we look at dashboard, it has some styling, has sort of a grid setup. So this grid is what gets us, if we look at what's going on here. So this is the standard 12-column grid setup. So this gives us a nice responsive feel. So if we go to sort of an extra small, then we take up 12 columns. So it's extra small, we take up 12 columns. If we're in the standard width, then this first one is taking up, what, seven columns. And this one, which is our user count, gets 5, and this one always gets 12, so it always gets its own row. Okay, so that's the grid layout, and then we're loading the ratings chart components. So that's here, ratings chart, user count component here, and then recent reviews, which is this table here. So the most simple one of these is the user count. So let's start there. So back in components, user count. So what's going on here? Well, we're pulling in this use query Apollo React hook, which is how we're fetching our data. We're also pulling in topography, styles, title for material UI. So we'll talk a bit more maybe in the next session about material UI and how we do some of the the styling and what components are available there. But for now, what I want to focus on is the data fetching. So we're also pulling in the GQL tag, which allows us to define GraphQL queries. What this is doing, so here we're defining a get count GraphQL query. What the GQL tag does is parses the string here in the template string into an AST or abstract syntax tree, which is what the representation that we use of the query when we send that with Apollo client. What's nice about that is, in the editor we get syntax highlighting and whatnot. There's other integrations we can use to connect this to running GraphQL APIs, so we can actually see in our editor if we have, if we're seeing a type that doesn't exist, and so on. There's lots of nice developer tooling we can hook that up to. But the basic gist here is first we define our query, wrap that in the GQL tag. Then we have a functional React component. We call this use query hook, passing in the get count query, which is just a really simple GraphQL query that's just calling the user count field on the query type that just expects to get back a single value. And we get back loading error and data objects from our hook here. Then when we render, well, first we say, okay, is there an error? So if our GraphQL query returns an error, well, then we don't want to bother with any of this, just return a paragraph tag that says error. And that's what's happening, remember, because we saw that error in the JavaScript console. It said, hey, this GraphQL query does not match the schema of the GraphQL API that's running. So we just return a single error in the UI. If there wasn't an error, then we would return total users. We'd use the typography from Material UI to give us some nice looking content. Then we check to see, okay, well, are we loading? So this GraphQL query goes through a few different states. First, it goes through a loading state where we maybe have sent the query. We didn't get back an error yet, but we didn't get back any data. So in that case, say, hey, this query is still running. It's loading. If it's not loading, if it's not an error, then we should have a user count value in this data object. And then in that case, then we can render, again, wrapped in this typography just for some styling here. But here's where we're getting out the actual value and rendering that in our component. And of course, we don't have a user count. So let's go back to our schema. And what we want to do, so if we take a look here, these are the types we've defined. What we need to do is now define a query type. So this is sort of extending the auto-generated query type that the make-augmented schema function gives us for free. And let's create a property count field. That's going to be an integer. And we're going to use the Cypher schema directive to define some custom logic here. So we've talked about this a couple times, but let's take a look in the docs. Cypher schema directive. So when we're defining our type definitions, we can add this GraphQL or this Cypher GraphQL schema directive that has a Cypher statement that gives us some custom logic, sort of like defining a computed field. Let's drop that in the chat. And that's exactly what we want to do here. We want to say, now let's match on all of the property nodes and just return the count. save that. That should pick up that there's a change in our schema. If we go in GraphQL Playground, let's try to run that. Property count, 49,504. Cool. Okay, so now that's in the API. If we go back to our user count component, instead of user count query, we want to run property count. And instead of data.userCount, we want to grab data.property count. And we'll say, instead of number of users found, we'll say properties found. Okay, so that'll rebuild our React application. And if we jump back, cool, so now this loads. So total users, let's change that to total properties. Cool, found 49,504 properties, cool. Okay, so that was a fairly simple one. A simple component to update our data fetching. The next one we want to do, let's do this chart. So this was a ratings chart. And this has a similar setup. We import some styles from, or some components rather, from Material UI. We're again using the use query React hook. We're importing some things from the recharts library to create a bar chart here. So we're running a query ratings count, getting stars and count. So this gives us a list of star count pairs. So what we were getting before was sort of a histogram. So for the number of stars, like 1, 2, 3, or 4, we're getting the count. So there's, I don't know, 10 reviews that have 5 stars, that kind of thing. And then passing that to our chart component. So in this case, we're going to need to define another custom field on the query type. So for our chart, let's show maybe for each city the average value, the average appraised value or something like that for each city, which we can define in a Cypher query. So let's call this city values maybe. And what is it going to return? It's going to return a list of, we'll call it city values. So this type we haven't defined yet. And it's going to be kind of a computed type. What is it going to be? Well, let's add this type. City value is going to have a city. It's going to be a string, so the name of the city. And then let's call the other field average, which is going to be a float. And that's going to be the average property value of all properties in that city. So we just need to define a Cypher query that's going to return the data for this list of objects. So we're going to do sort of an aggregation for all properties in each city. So what's that going to look like? Here, let's break this out into multi-line. We're going to, there we go. And then, so we're going to lose our syntax highlighting, but I assure you this is valid. GraphQL SDL syntax with the triple double quotes for multi-line string arguments. Okay, so what's our Cypher query? It's going to be match on all the cities that have a property. So every property that's in a city, and let's filter out only properties that have a total value. So this is every property has an assessment, an assessed value. The county says your property is worth this much money, and that's what this value is. And then what we want to do is for every city, calculate the average p dot total value as average. So this will give us kind of a group by city aggregation, calculating average total value for each property in that city. And then what are we going to return? Well, we need to return something that matches this structure. So we'll return an object that is composed of city for the key and city, which is this value. And then same for average, and give it a name. I don't know, call it object. Okay, there we go. Got our syntax highlighting back. So what was the problem there? Oh, it wasn't on a new line. Okay, if we put on a new line, then VS Code can handle the triple double quotes for multi-line string arguments. Cool. Okay, so let's see if that works. So we'll jump back to GraphQL Playground. Instead of property counts, what did we call that? City values, where we have city name and average value. Cool, looks like that works. So we get a bunch of cities and then the average value of properties per city. Great. Let's jump back to our ratings chart component. And what we want to do, let's just copy this query, city values. And then in our React component, so we're using the use query hook. We are, instead of ratings distribution, let's say average city property value. And then we're using the bar chart component from this recharts library. So the data is not going to be data.ratingsCount, it's going to be data.cityValues. And then for the x-axis, which I think back to high school math goes that way, on the x-axis, what do we want? We probably want the city. Label, that looks fine. Let's change the name though, the label to city. And then for the y-axis, that is going to be, what did we call it? Value, average. Okay, so we'll save that. And let's see what that looks like. Cool, there's our chart. So West Yellowstone is significantly skewed here with average value of 3.2 million. Big Sky looks like that's number 2 with average value, what's that, like 900,000 or so? Okay, cool. So there's our chart. The next thing we're missing is this table. In the table, so previously we were showing business reviews. This time, let's show some property listings, and we'll show like the address, and then some attributes about the property. So that is going to be our recent reviews component. Okay, so here's the query we were running before where we're looking at the most recent reviews. Let's jump to GraphQL Playground to write our updated query, make that a little bigger so it's easier to read. So what would make sense here? Instead of recent, how about, since we don't really have a time component here, maybe let's just show like the most expensive. Maybe that's interesting. So let's look at the first 10, order by total value descending and address. And total value. Okay, some of these are missing an address. So our table doesn't look wonky. Let's add a filter. So we'll say filter where address is not null. Will that work? Yes. There we go. Okay, so these are the 10 most expensive assessed properties in our database that have an address. What else would be interesting? I don't know, the number of bathrooms, number of full bath and half bath. And if they're in a subdivision, then we'll have the name for the subdivision. Okay, well, none of these are in a subdivision. That's not very interesting. Let's maybe add another filter here. Let's bring this down so it's a little more readable. So we're filtering where the address is not null. And then we're going to say in subdivision, where the name is not NA. There we go, that works. Although some of these we don't have bedrooms, full baths, or half baths. So let's just add filters for all of those. So bedrooms, not null, and full baths, not null. So just adding some filters here just so that we make sure that our table looks nice. Okay, so that should be enough to show in our list. So most expensive properties where we have enough information to render a table. Okay, cool. So we have the GraphQL query, so that runs, but if we look at our React app, we're still throwing an error because we're trying to pull out data that doesn't exist here, right? So we don't have a business and user and so on. So what do we want the headers for our table to be? Let's call these, I don't know, most expensive properties. And here's our error. In our React app, we're calling map where we don't actually have reviews. Okay, so what do we want to show? Well, let's show the address, the subdivision name, the number of bedrooms, and actually what would be more interesting, I think, is the square footage of the house. Maybe that's a bit more interesting. Yeah, there we go. You can see that our scraper was probably not great in some aspects. I'm sure there are some cases here where we grabbed maybe the square footage of the garage or something. Not sure what is going on there. Anyway, because we have a 800 square foot house, it's one of the most expensive. Doesn't quite make sense, but anyway, we have value. That's fine. We can revisit our scraper later. So bedrooms. Square feet, and then total value. Okay, cool. So if we look at our query, this is going to render the header for the table, and then we want to iterate over property. So looking at our GraphQL query, data.property is going to be an array with these values in them. So the ID, oh yeah, so every row needs a unique key, which we have. That is the property ID. So we'll bring that back too. So we'll say row dot ID. Row, the second one is the subdivision name. So this is going to be row in subdivision name, right? That matches the query here. I guess I could have said dot in subdivision. Okay, and the second one is the number of bedrooms. That's just going to be row dot bedrooms and square footage. Oops, I know I did this wrong. The first one is the address, not the subdivision. So let's copy this row. This is going to be row.address, square foot, and then total value. Get rid of our extra row there. And let's see if this works. Cool. Looks like it mostly worked. So we have address, bedrooms, we're missing square feet and subdivision name. What happened there? Oh, well, square foot we don't have because we didn't include that in the query. There we go, there's square footage. And subdivision name, we don't have. Where are we missing that? Row dot, maybe I spelled it wrong, in subdivision dot name. Okay, let's do a so instead of rendering our table, let's log our data. So for some reason we weren't getting subdivision. If we jump to the console, right. So in subdivision, so we were saying in subdivision.name, but in subdivision is an array of subdivision objects, right, which we can see here. So let's fix that. So row dot in subdivision, well, let's just grab the first one. So index 0 of the subdivisions, and then call name on that one. There we go. Okay, cool. So now we have queried our GraphQL API using Apollo Client React hooks to populate our dashboard components. That is using our Neo4j GraphQL JS library to generate Cypher queries from GraphQL and sending that to our local database to fetch data to populate our application. That's good, but we want to deploy our database now somewhere to the cloud. So I could push this out to Netlify right now, and that would be fine for the front end and for running our serverless GraphQL API that we set up last time, or I should say in the first session, we set that up on Netlify using Netlify functions. But it can't query my local database on my machine if you're looking at that from home, so that's not very interesting. So what we want to do now, let's see how we can deploy this database piece of this, I should say, to Neo4j Aura. So we'll create an Aura instance, or a cluster, rather, I should say, create an Aura cluster. We'll push up our local database to Aura, and then we'll deploy our updates to Netlify, both to the React front end and the GraphQL API. And we'll have that querying our Aura Neo4j instance instead of the sandbox or my local database. So I'm going to log into Aura. I already have an account, so we'll click login. And we'll sign into Aura. Oh, I think I've already signed in, so I didn't go through the auth flow though. Let's just go ahead and create a database. What are we going to call this? How about Willow GRANDstack? You can choose a region. Sure, US Central 1 is fine. You can scale this up. This doesn't need to be a massive database, just a 2 gig is probably fine. You could probably just get away with a 1 gig. Okay, here's my credentials. Let's paste these somewhere. Yes, I've stored my credentials. Okay, so this is spinning up. So I'll change the password later. So don't worry about that. Let's take a look while this is spinning up at some of the other features that we have in Aura. So in this import tab, this is something we're going to need to think about. How do we import data into Aura? Well, we have all of those those load cipher scripts that we ran last time, which we could run. That would be fine. The only thing that is a little bit problematic is we have like the GeoJSON files and the CSV files. So we'd have to put those in like an S3 bucket or somewhere that that Aura could reach over the network if we wanted to do that. Instead, what we can do is push up an already existing database. So there's some tooling that allows us to do that from Neo4j Desktop. So this is kind of a wizard that walks us through the process of using the command line tooling to do that, which I'm sure is perfectly fine. But instead, what I want to do is use another graph app. So I'm going to go to install.graphapp.io. If you haven't seen this is the graph app gallery. Paste the link in the chat there. So previously we were looking at GraphQL Architect, which is this graph app that allows us to build GraphQL APIs using Neo4j Desktop. And that was cool. There's a whole universe of these graph apps that do lots of other things. Things like the ETL tool for importing data from relational databases, Halen, which allows us to monitor our cluster, things like Neuler, or the Graph Data Science Playground, which allows us to use the Graph Data Science library with a nice UI and some data visualization in there. So there's all kinds of graph apps. I'm interested in this one, the Neo4j Cloud tool. So this is a graph app that has some nice UI functionality for working with Neo4j Aura. I can install this either just by clicking this link, which is a deep link into Neo4j Desktop, or in this case, what I want, is to just copy that URL. And if I go into Neo4j Desktop, this was already selected, but the way we get there is clicking on this Graph Applications sidebar and pasting that install URL there, which will install the Neo4j Cloud Graph App. So while that's installing, let's jump back to Aura. Okay, so we were looking at import. There's also the Connect tab. So the Connect tab is nice because it shows us we can choose our different databases here, and it will populate the connection credentials in some scripts here. So how to use the various drivers. For Neo4j, there's a GraphQL example that shows us how to spin up a GraphQL API that connects to our Aura instance. What else? We have documentation for Aura, and then the feedback portal. The feedback portal, if we look at feature requests, this is a good one. So if there's some features in Aura that you're interested in that you're not seeing, definitely take a look here in the features requests forum for Aura. This is great. It's great for knowing, from users what features would you like to see that you're not seeing on Aura, and then we can also give you some indication of what's going on. For example, the top rated one is Neo4j 4.x on Aura, and this is in progress. This is something that's being actively worked on. Okay, cool. So that is the general functionality for Aura. While this is running, well, we're still waiting for our Willow database to spin up. Let's take a look at the database dashboard. So this is for an Aura database that I have that's already running. And this one, I think, does not get very many active requests, but what sort of information can we see in the dashboard? So we have lots of metrics, both how many queries are coming to the database, CPU usage, that sort of thing. If we want to, we can just sort of drag a dump file from Neo4j Desktop or from some other database. So a dump file is kind of an export of Neo4j. So this is another easy way to just upload some data. We have our same code snippets here. We have the ability to export and restore backups. So that's really nice. And then we can scale our database as well. Okay, cool. So while this is spinning up, let's refresh just to make sure that didn't spin up while I wasn't looking. Oops, still going there. Let's jump back to Neo4j Desktop. It says, yes, I do want to install the Neo4j Cloud tool. Let's go ahead and fire up the Neo4j Cloud tool. So this graph app is going to walk us through the process of uploading a database that we have installed in Neo4j Desktop into Aura. Let's start that again. There we go. So it's going to walk us through the process for uploading a database that we have in Desktop to Aura. Now, why would we want to use this instead of, I saw in the console for Aura that I could just drag in a dump file there. Why wouldn't I just do that? Well, what's nice about the Graph app is we don't have to go through the process of creating our own dump file. Instead, that happens automatically with the Graph app. So this Graph app is saying, hey, you need to have an active connection in Neo4j Desktop to an Aura database, but you're currently connected to a local instance. So here's how you create an Aura remote connection. So if we jump back to Desktop, so currently I have, this is the Willow GRANDstack project, and in here I can have multiple database instances, DBMS instances. Right now I have one Willow GRANDstack. I'm going to create a new one, and instead of a local graph, I want to connect to a remote graph, and this is going to be my, let's call this Willow Aura. This is going to be my Aura instance, and I need the connect URL for my Aura instance, which is here. So this is now done running, or I should say not running, done spinning up, and the database is up and running. So we'll paste in our connection credentials there. Username and password, the default is Neo4j, and then let me grab where I had pasted that password before. Hopefully no one was super fast and went in there and changed the password when I wasn't looking. Okay, so now what we have is a remote connection to a database that's running within Neo4j Desktop, but now running in Aura. And if we go back, oh, right, and then we need to connect. So in Desktop, we have one active database at a time. And this is nice because what it means is that for any of the graph apps that we're running, if it's like Neo4j Browser, if it's Bloom, if it's GraphQL Architect, any of those graph apps, it knows the currently running database, whether it's a remote database or a local database. So we're going to activate our Willow Aura connection and then switch back to the Neo4j Cloud app. And now instead of giving me an error, it says, hey, is this the remote Aura database you want to use? Yes, it is. Check for existing databases. So because we're uploading a new database, it just wants to make sure that the database is empty or give us a warning that says, hey, there's some data in here. That's not cool. So now we need to select a project. We're interested in the Willow GRANDstack project, and the database is this one. So let's go ahead and import that. It asked me if it wanted to run some background process. I said yes. So what is it doing now? So now this is creating the database dump. So this is creating the export from our Willow GRANDstack database. And then it's going to use those command line tools that we saw here, right? So we were starting to use this Neo4j admin push to cloud. Basically, what the Graph app is doing is running these command line tools behind the scenes so that we don't have to worry about it. Okay, so any questions so far? Feel free to fire away in the chat if anyone has any questions or feedback. While this is running, this will take, I think, a bit to upload and restart the database. Let's talk about what we want to do for the next bit of the UI in our application. So here's what we have so far. We have this dashboard where we have kind of a chart, a very, very simple React app. It's just giving us a count of properties and then listing some properties and their attributes. So what I want to do next is now start to think about the functionality of our real estate application. So if we go back to GitHub, and if we look in our README, I think the new GitHub design doesn't like my hidden arrows markup here in the README. Anyway, okay, so we had started to sort of list out some of our requirements for the application, right? So we know that we want to allow users to search for properties by city and view details. We know we want the user to be able to use the filters to say, hey, I want a house that's at least this many square feet, has at least this many bedrooms, and so on. View it on a map. We know we want to be able to draw bounds on the map, right? So let's take a look at how Zillow does this. So if we look at Zillow, the data we have is for Bozeman for sale. Let's remove boundary. So it's showing this boundary is the boundary for the city of Bozeman. We have data for Gallatin County, which is a bit bigger than that. But in our map, we want to be able to have a map view where we're sort of scrolling around on the map and we see properties sort of pop up. We can view details about the property when we click on it. Look at photos, scroll through and look at attributes of the property. So the map has to, kind of be hooked into our search functionality in our GraphQL API. So we need to, have some way to search for properties that are within the bounds of the map, right? So that's one thing that we need to do. But then also we need to be able to handle searches for properties within a polygon. So we can draw on the map. So maybe I want properties that are on this side of the mountains, and I don't know, maybe like this neighborhood that's sort of on the northeast side of these streets maybe, right? So I can draw some arbitrary polygon, and now I'm only showing properties that are within that arbitrary polygon boundary that someone drew. So anyway, so these are the functionality that we need to be able to work with in our map component. Last time we saw how to do this essentially from the API side, right? So we saw how to use the radius distance for filtering property searches in our GraphQL API that we kind of get for free just by having that location property in there. And then we saw how to, we were doing point and polygon, which is very similar to the type of search we want here. So we know we can use that spatial algorithms library to do this sort of polygon search. So we know we can do it from the API side. What we need to think about is how to do it from the UI side of this. So what I want to do next is add a map component to our React application. Okay, so that was a little bit of a detour on the functionality that we're looking for. Let's check in with our import. It says import succeeded. If we jump back to Aura. Cool. So let's open this. Ooh, we can open it with browser or with Bloom. Let's go on a little Bloom detour. So if you're not familiar with Bloom, Bloom is a graph data visualization and graph exploration tool. Let's just find my password again. Here it is. No, I don't want to save it. Yeah, so Bloom is this graph visualization tool that lets us interact with Neo4j databases visually. Let's do a new scene. Cool. So Bloom allows us to visually and interactively explore the graph, which is neat. First, Bloom generates a perspective from our data. So this allows us to configure what and how the data is shown to us visually. So we can exclude any of these properties from being shown. And this is nice from a security perspective. We want to say, hey, certain users have access to this perspective, which excludes maybe, I don't know, the name of the owner or the address of the property. And we want to grant that to users with limited access, or I don't know, something like that. We can choose the caption, use address. We can also, what else do we, oh, we can also choose icons. So if we go in the styling here, let's toggle off our rule-based styling. We'll talk about that in a second. But let's set an icon. This is a property. So do we have any house icons? Oh, we have mini house icons. Great. How about this one? That looks fine. So, so how do we use Bloom? So we can use this sort of natural language search functionality. So let's search for property where the number of bedrooms is, I don't know, 9. I don't know if we even have any houses with that many bedrooms. That's ginormous. Hey, we do. We have a few. Cool. Okay, so then we can like click on one of these and view some details. So this is Rocking Horse Drive and Bozeman. We can then do interactive expansions. So if we want to say, okay, what city node is it in? Yep, it's in Bozeman. Let's just expand all relationships. We can see that it's in this neighborhood. Let's expand out from this neighborhood node to see all of the other properties that are in this neighborhood. And there are a lot. There are like 3,000 of them. Another thing that we can do that's nice is, let's close that property card there. The thing we do that's nice is we can configure the styling to be based on values of properties on the node or relationship. So if we jump back here to our rule-based styling for property nodes, we can, instead of single, if we go to range, so these are now property-based styles on total value. Let's do a size. So let's change the size of the node depending on the value of the property. So if it's if the value is high, we'll make the node bigger, and then the value's low, let's make it smaller. And this is useful for things like when we want to do, when we're running some of the graph data science and graph algorithms. So if we run, say, like PageRank, and we want to see the most important nodes in the network, we want those to be bigger. If we're running like a community detection algorithm, we want nodes in the same group to be the same color, and so on. But it's useful for at a glance. We can see sort of, okay, well, here's a property that's assessed value is a lot lower than, say, like this one. So on. Okay, so that's Bloom. Bloom comes with Neo4j Aura. It's also included in Neo4j Desktop, so we could have done this in Neo4j Desktop as well. But I got excited when I saw it in the dropdown there. So okay, little detour from Bloom. Let's go back to Neo4j Browser for our Aura instance. I guess we don't really need to look at our data in Neo4j Browser. We looked at it in Bloom. We confirmed that the data was there, so that should be good. Instead, let's deploy now our application, both the React app and the GraphQL API to Netlify. I guess maybe let's just test it locally first and see how we can do that. So jump back to Visual Studio Code. Let's take a look at our .env file. So here we're specifying which database for our GraphQL API to connect to. And in this case, I want to connect to this Aura instance. You're going to see my password again briefly, but that's okay. We'll change that later. So here's our password, and then I'm going to uncomment this Neo4j encrypted equals true line because I want to use a encrypted connection with Aura. And then I need to restart my server because I don't think that gets picked up by the watcher when I change that .env file. Okay, so if this works, we shouldn't see any changes when this reloads. We should actually just see the same view of this dashboard that we had when we were running this locally, but now it should hopefully connect to our Aura instance. So we'll wait for this to compile the React build. Actually, while we're waiting for that, oh, there we go, now it's done. Let's reload that. And there our data comes in. Cool. So that is our locally running React application hitting our locally running GraphQL API. But now instead of the GraphQL API talking to our local Neo4j instance, it's talking to our Neo4j Aura instance. So now we can deploy our React app and our GraphQL API to Netlify, which will then talk to talk to Aura. So let's do that. So first of all, we set this up on Netlify previously. Let's just jump into Netlify and change the database that we want to connect to. So it should already be signed into Netlify. Let's see if we can remember which project this is. It's not this one. It's not this one. Might be this one. Deploys from GitHub. Let's see which repo. Yes, it's going to do Willow GRANDstack. Cool. So the first thing I want to do, so this is hooked up to our Willow GRANDstack GitHub repo. We did that when we first set this up. If you want to see how to connect that, I think we did that in the first session. So that is up and running. It's basically Netlify is just waiting for any changes to come through in GitHub, and then it will build and deploy based on those updates. But the first thing we need to do is change the credentials for the Neo4j database that our GraphQL API is going to talk to, and that I believe is going to be in the deploy environment variables. So here, this is these are the environment variables for our Neo4j sandbox instance, which I'm sure has since expired. So let's change these. Oops. So here's our password for the Aura instance. If I go back to Aura, copy the credentials. Neo4j user is Neo4j. And then I need to add a new variable, which remember we uncommented that line in the .env file, which is setting Neo4j encrypted. Is that what it was called? I think so. Neo4j underscore encrypted. Okay. Cool. So we've updated those values for the environment variables for our build for Netlify. So now we just need to commit our changes, and when we push those changes to Netlify, it should build using those new values for our environment variables. So we have some untracked files here in the data directory. This is the shape files and some of the CSVs that we built. So I don't want to check those in, but I do want to, let's look at what we changed. We changed API source initialize, API source schema.graphql. Those are the changes we made to our GraphQL API. And then we changed components, each one of our components, the ratings chart, the recent reviews, and the user count. Let's commit, and we'll say updates for property data model, something like that. That'll run prettier, make sure my code's formatted correctly. Push that up to master. Okay, so that is pushed to GitHub. We can verify that if we take a look at GitHub and look at the commits. Updates for property data model 29 seconds ago. Cool. Now, if we go to Netlify and look on deploys, we can see that we have a deploy that is building, and we can sort of watch this run. So if you remember what this is going to do, let's take a look at our build configuration here, which is just in the root in netlify.toml. It's going to run this command after it clones down the repo in Netlify, which is basically just building the API project and deploying that as a Netlify function, which ends up being deployed to AWS Lambda, and then it does also a build for the React application and just serves that over the static CDN. The Netlify function that gets built is here in source functions GraphQL. It looks very similar to the code for our local GraphQL API, except it uses the Apollo server Lambda version of Apollo server. But otherwise, I mean, it's still using our make augmented schema from Neo4j GraphQL JS, pulling in the GraphQL schema type definitions that we defined. Cool, so that's what Netlify is doing. We can track its progress here. Might take a little bit to build the React app. Cool, anyone have any questions? Don't see anything in the chat, so that's cool. But again, feel free to ask away in the chat. So while this is running, let's get back to talking about our map. So we talked about the requirements that we had for our map in the application. We need to be able to sort of add annotations to it. We need to be able to draw on the map. So sort of the ability to add arbitrary layers. I think most JavaScript map libraries let us do that. I've used Leaflet in the past, which is an open source JavaScript mapping library, which is pretty nice. It allows us to add annotations, things like that. I've also used Mapbox, GLJS, which I believe is based on Leaflet somehow. There's some relation there. I think the maintainer of Leaflet now works at Mapbox, something like that. So it has a similar API, but I think is maybe a bit more powerful and has integration with Mapbox for things like some, I don't know, custom style and different tile sets, things like that. I'm not sure what all additional functionality it adds, but I've used both of those. I have also, sort of used some of the React components that wrap these. Looks like our Netlify deploy is done. Preview deploy. So nice thing about Netlify is it gives us an API, or sorry, a URL for each one of our deployments. I just refreshed there. I was getting error initially. I think it just needed a refresh. Cool. So here's the URL for our app running on Netlify, talking to our Neo4j Aura instance that we just deployed. So we're serving the static React content through the Netlify CDN. Our GraphQL API got deployed to AWS Lambda as a Netlify function. And that GraphQL API is querying our Neo4j Aura instance anytime we run a query. Cool. Okay, so we're an hour and a half in, and we're starting to talk about maps. I think let's save the map bit for next week. This seems like a good stopping point. So next week we'll start to explore adding a map component to our application. So maybe instead of here where we're searching, previously we could search for like users by name or something. Maybe we'll start to add our property search component there where we have a map view, taking advantage of some of the GraphQL filtering functionality that we built. Cool, so I think we'll call it good there for today. I will push up the code to GitHub that we worked on today, but we already did that, so that's this commit here. So just to recap what we did for today, first we finished off working with GraphQL Architect in Neo4j Desktop. We were using our the GraphQL schema building functionality in GraphQL Architect. We then exported that into the project where we were building our GRANDstack app previously that we had pulled down from the GRANDstack starter project. So we updated the GraphQL API. Then we got our React components that were there previously for fetching data about business reviews. We updated those now to use our property information to show kind of a simple chart and a simple table. And then we took a look at Neo4j Aura, and we provisioned an Aura cluster, and we used the Neo4j Cloud desktop app, Graph app, to push a database from Neo4j desktop up to Aura. That was useful. We had different iterations that we did on data import. So it was useful to be able to do that locally instead of having to do that on Aura each time. Then once we had the database we were ready to deploy to the Aura cluster, we did that with our Neo4j Cloud app. And then we deployed our React app and our GraphQL API to Netlify, where it is now talking to our Aura instance. Cool, so that's what we did today. Next time we'll pick up where we left off, starting with adding a map component, which I hoped we were going to get to today, but just ran out of time. So hope you will tune in next week. As always, it's every Thursday at 2 p.m. Pacific time on the Neo4j Twitch channel. So we'll see you next time. Thanks for coming today. Cheers.